Geometry, Unit 3, Lesson 1. I can identify and use properties of parallelograms to solve problems. So a parallelogram is really a quadrilateral. So we're going to be working with polygons that are all quadrilaterals. And what is that? It's four-sided. And remember, a polygon means the figure is closed and it's made of line segments. So these are examples of quadrilaterals. Four sides, which is quad. All right. Lateral means side. And the key is that it's closed. So the non-examples show this one is open. That's the problem there. This one has a curve. Remember, it has to be line segments, no curves. And this guy right here crosses on top of itself. So that's no good either. Okay, so parallelogram is a quadrilateral with the following properties. Let's first talk about how to name it. So you're going to name a parallelogram three different ways. And this symbol actually means, you speak it out loud, parallelogram. It's kind of nice. It saves you from writing this word over and over. So I'm going to go ahead and highlight the vertices. This is a vertex, this is a vertex, this is a vertex. So is this. Okay? And now I'm going to name it. How about A, B, C, D? Parallelogram A, B, C, D. Is there another way to name it? Sure. Parallelogram. And pick any one, any letter. How about D? Here's the key. Go in any direction you want, but then stay in order. So if I go this way, I have to say C, B, A. If you did this, parallelogram D, B, you went across, C, A, that is no good. You can't go out of order. Whatever one you pick, choose a direction and stay in order. How about one last time? You can hit pause and try it yourself. Okay, maybe I'll start at C and I'll go this way. Parallelogram C, D, A, B. Any of those work. Notice I used every letter in the parallelogram. Okay, so let's take a look at the sides now. If you take a look, the opposite sides are parallel. That's why we call it a parallelogram. So how am I going to annotate this? Well, I'm going to start by coming in here and putting an arrow here and an arrow here to say that those sides are parallel. Now I can't put a single arrow here because if I did this right here and this, it would mean that all four lines are parallel, which is not true. So I need to put doubles. So the single arrows, those segments are parallel to each other, and these double arrows are parallel to each other. So I want to say opposite sides are parallel. Okay. So not only are they parallel, the opposite sides also happen to be congruent. So this side I'm going to put a tick mark, and this side I'm going to put a tick mark. Now, these sides here are also congruent. But notice I didn't put single tick marks everywhere because that would say all four sides are congruent, and that's not required to be a parallelogram. So opposite sides are also congruent. Remember your symbols for congruent and for parallel. Okay. That parallel is a little rough to look at. Let me go over it in pen. Okay. So let's take a look now at the angles. And we learned if we extended, for example, this side here, and this side here, and this side like this, you make a transversal cutting two lines. And if these are parallel to each other, then these are consecutive interior angles. And you know that these are supplementary. The acute and the obtuse add up to 180, right? So consecutive angles are supplementary. While the opposite angles, take a look. Let me go with this angle here and this angle here. They're opposite angles, and they happen to be congruent. While, let's see, how about this? This angle here, I'm going to go with 2 arcs to say it's different. Those are congruent too. So these are going to be supplementary. Okay. They sum to 180. So do these, so do these, so do these. And the opposites are congruent. Okay, and finally, the diagonals. If I were to go ahead and sketch some diagonals in here, diagonal connects opposite vertices. There we go. And you'll notice the diagonals actually bisect each other. So if I were to take a look in here, this long diagonal cuts the short one into 2 congruent segments. And this short diagonal bisects the long diagonal into 2 congruent segments. Notice they're different lengths, the blues and the oranges. So the diagonals come through and bisect each other. So our job today is to use, first to be able to identify these properties, but then also to use them to solve some problems. So let's come down and try them. And you want to refer to your notes all the time. So how do the sides relate to each other? How do the angles? How do the diagonals? So the problems I gave you to start actually don't have any pictures. I'm making it hard on you. So let's do the first thing we're supposed to do, which is find our find. ABCD is a parallelogram with diagonals AC and BD intersecting at point E. If the distance from A to E is 3, find the distance from A to C. Here's my find. Now, I don't see a picture, so I better go ahead and sketch one. I need a parallelogram, so I'll just sketch a little parallelogram right here to start. And I don't know, let me just start putting down A, which means this would have to be B, C, and D, or I could have gone the other way, B, C, and D. Now, I need some diagonals, and how did I know to make a parallelogram? Well, look at the key word. Okay, and then I'm going to go ahead and sketch in my diagonals. There they are. And they intersect here at point E. Now let's label some more things. The distance from A to E is 3. Where's that? A to E. Oh, okay, that's 3. Find the distance from A to C. From A all the way to C. So what am I really looking for? My find right here, which I'll highlight in yellow, I'm going to highlight also here. I really like annotating. And you can see I want this distance. So what do we know? Well, what do we know about diagonals of a parallelogram? If you look back up over here, you can see in your notes that these diagonals bisect each other. So these segments are going to be congruent. So if I come back here, I know if this is 3, so is this. Therefore, what do I know? AC is going to equal to 6. So the distance from A to C is equal to the distance from A to E plus the distance from E to C. This one plus this one. I already know this one is 3, and it turns out the other one's 3. And I know this is a little simple, but you're going to need this kind of approach when you get harder algebra. Because instead of saying 3, I could say 2x plus 5 or something. Okay, let's try one more. If you like, you can hit pause and try it yourself. Okay, I'm going to go ahead and start it now. Hit pause if you want to try it and then see if you can do it. Here I go. What's my find? Solving for x. And notice the key word. It's a parallelogram, so I'm going to sketch one real quick. I don't see a picture. W, X, Y, Z. How about, let me see, Z is 120, so I'm going to choose an obtuse angle for that. I'm going to go ahead and annotate. So if this is Z, I have to go in order, right? Z, how about Y, X, W? Z, Y, X, W. And now, let's mark up anything else we know. Remember, opposite angles are congruent. Okay. And it says the measure of angle Y is 3x. I can put that there. Well, that would be 3x over there too, then. Well, wait a minute, what's the relationship here? Oh, yeah, if I extend these, and I know these are parallel because they're a parallelogram, these are consecutive interior angles. So I know, for example, that this angle here and this angle here are supplementary. So I can say 3x plus 120 has to equal 180. Take away 120 from both sides. 3x is equal to 60. Go ahead and solve. Did I find my find? X. Yes, I did. I'm good to go. So remember, find your find. Look for a keyword and sketch a picture. Mark it up and annotate. Figure out the relationship you need from your notes. Get that equation and solve. Good luck.